Hello friends, my name is Sujit and welcome back to my series of learning microservices using .NET. So in last class we discussed like how we have designed the multi-stage Docker images, and we looked inside the Docker image, like how those files are organized inside a Docker image using the Docker desktop tool. So today we will move one step ahead after the Docker. So after creating the Docker images and creating the container, and we also run the container in different operating system. Like I run the container in one of my Windows system. I run the same container in one of my Linux system. So in different environment we run where the .NET runtime was not pre-installed. So that we already checked, and I hope everyone is clear about that. So next thing, after the Docker image and Docker container, we will move towards the Kubernetes. So today we will discuss something about the Kubernetes. So fine. So in Kubernetes, like what we are doing is, so let me go to the project structure. So here today I have created the two different projects. Like one is order service and second is the platform service. So we all know the Docker file we discussed, and here also we have the Docker file. So two Docker file for two different web API. Okay, so technically we can say like order service is one microservice, and this is sorry, not microservice, one service inside a microservice, and platform service is one service, another service under the microservices. So we are done till the Docker file. So today we will be going to discuss something about the Kubernetes. Okay, fine. So in Kubernetes, like what we have to do is like we have to create some YAML files. Okay, so YAML, it is YAML or .yml, whatever you can write. So both are fine, both are acceptable. So the good practice is like you should create one folder like K8s. It's not like hard and fast rule that you have to create with this name, but like I like this name. Kubernetes means there is some reason why it is called K8s, so you guys should explore this. So I have created one folder inside this project, and inside this folder I have created the YAML files. Why? Because coming to Kubernetes understands the YAML file. So here we can see, let's see the how YAML file looks. So this is like tab indexed YAML file. So it is tab indented. So here is like API version and like what is the kind of this YAML file, metadata, and all these container details. So guys, don't worry, I will explain line by line, like how I explained the Docker file line by line. Similarly, I will explain each and every line, what is the meaning of each and every line. So don't worry for that. So today I'm going high level. So today I will cover some part of practical and some part of concept building, or the theoretical part you can say. So today I'm going to focus on that, and in next class maybe like I will be focusing more on the practical side and explaining each and every line and like how these things are going into the Kubernetes, like more of the practical concept. But today we will kind of mixed approach, practical as well as some theory. Why? Because concept is also necessary. Why? Because in last 3 classes I have mostly done with the practical things. So today I am thinking of like giving some concept, some basics of the Kubernetes, and like how, why microservices, how Kubernetes help to design the microservice architecture. So all these things we will discuss today. So yeah, so here this is a YAML file, and mainly you should focus on this for now. So what we have done is, like, here in the container section we have given some name. This is some name of the container, but make sure the same name should be maintained here in the match levels. And the image, okay, so this image is same image which we created from the Docker file. You must be remembering, right? Like by building the Docker file, like docker build, and we gave some image name. So from the Docker file we created the image, Docker image, and that Docker image we pushed into the Docker hub. Okay, so let me go to the Docker hub quickly. So here we are here in the Docker hub. So in my Docker hub you can see, like, I have only two images are there, platform image and order image. So this is these are the order service and the platform service. So for them, for this the platform image, and this is the order image. So this is the image. Okay, so whenever I will do something on this YAML file, something will happen. So what is this something and something? I will explain in some time. Okay, so Kubernetes understand the YAML file. So first thing, and second thing, like here I am giving the image name here. So by default what it is doing, like, it is searching this image in the Docker Hub repository. Okay, so means whenever I am switching to, or I am jumping to Kubernetes, I make sure my images are somewhere in some repositories or container registries. So for now I have put my images in the Docker Hub registry or repository. Okay, based on the requirement, like, people are keeping their images in AKS, like Azure Kubernetes Services. So there is this something called ACR, Azure Container Registry. So in there also they are keeping. So make sure wherever you are keeping, you are giving the absolute address here. Okay, so since I am not giving any URL anything, I have only given the name, means it will go by default, it will go and search in the Docker Hub repository. Okay, so make sure this image is uploaded to the push to the Docker Hub image repository. Okay, fine. So fine, so this is my YAML file, and when I will apply this YAML file, okay, there is something called apply. Okay, I need to apply these files. So when I will apply these files, it will give the output. And what is the output? The output is pod. Okay, so okay, fine. So let me start explaining some theoretical concepts. Let's get some idea, basic idea of the concepts. So okay, so whenever I am I'm like writing the YAML file, right? So in that YAML file, what is happening, like, in that YAML file I have given the container. Okay, so this YAML file contains the container details. Okay, so technically what happening, so whenever I apply that YAML file in Kubernetes, so it will be creating a pod, something called pod here. Okay, so there are two pods here in my example. Why? Because I am not taking the very big example, but in real time, in production scenario, there might be some 20 or 30 pods. Like in my working experience in one of my company, where I was working, so there we had around 20 to 25 pods. Okay, so what we came to know, like, from the like whatever Docker we gave, what Docker gave us image. So from that image we build the container, and now from this container, where we are going towards, we are going towards the pod. So we are creating a pod in the Kubernetes. Okay, so now this is a pod. Let us suppose this is a platform pod, and this is one order pod which I have just now created. Yeah, so now what we have done is like we have assigned our containers which we created through Docker file for some of our web APIs. Now we have assigned those to Kubernetes. Okay, so very first thing what we had one web API. That web API, through Docker file we created the Docker image. That Docker image gives us the container, and now that container we have handed over to Kubernetes. Okay, so why we handed over, why we gave our container to Kubernetes? So there must be some reason, right? Like why we are giving our container to Kubernetes. Okay, fine. So Kubernetes is a very nice guy. Like I can say it's a very one of the nice tool or platform we can say, which help us to achieve the microservices architecture. Okay, so whatever we are discussing, right, like microservices architecture, okay, auto scaling or whatever, so this thing is possible through this Kubernetes platform. Okay, so let's see the capability of Kubernetes, like what Kubernetes is helping us to do. So like Kubernetes help us to perform auto scaling, self-healing, load balancing, and efficient resource usage. Okay, so maybe you are not able to understand these things, but I will explain this again and again. I will be switching between the slides and I will explain, don't worry for that. So like how, what are the responsibilities of the Kubernetes is like auto scaling. Okay, auto scaling means scaling up our application. Okay, so let us suppose our application is running, and there is some event happened. Let us suppose some festive season came. Okay, and let us suppose some jewelry shop app is there. Okay, so generally normal days like jewelry shop apps are not so crowded. Okay, but during some festive seasons, definitely like more people will hit that website or application, right? So there will be more load on the server. So our system should be able to handle that load. Like it should not be telling you, okay, sorry, I am run out of the memory, I am run out of the CPU, I cannot serve you. It should not be the case. If that is, then we are not actually solving the problem of the customers. Okay, so our application should be scalable. Okay, so that scalable feature is given by the Kubernetes auto scaling. Self healing means due to some reason, if some part of the application is failing, then that application should be correct it itself. Okay, and the load balancing, you know, like if some more number of traffic is coming to some um, like some API, then we should be mirroring. Like earlier in old days, like we used to do mirror, right? So it is going as per the load, traffic load, it is switching to another server. So that kind of load balancing and efficient resource usage. So yeah, so these are the major features given by the Kubernetes. Okay, so we will see, like we will try to map each and every line with the microservices, how these things are getting true with the microservices implementation. Okay, so I will come to this again. So like Kubernetes, okay, fine. So first of all, let's try to understand like what is Kubernetes. So you must have seen in web or net, if you google this, like you will find Kubernetes is the container orchestration tool or container orchestration platform. Okay, fine, perfect. Myself, when I started learning Kubernetes and microservices architecture, I was like very confused about the word, like what is the orchestration, what is the exact meaning of orchestration. So it took time for me to get the knowledge, understand the concept. So Kubernetes is container orchestration tool. Okay, so what is the exact meaning of orchestration? Exact meaning of orchestration, like let's see the di dictionary meaning of orchestration. Okay, fine. It might be sounds funny, but okay, I want to dig deep in this. I want to make sure like you have the clear fundamental uh, understanding. So that's why I'm digging so deep. So if you go by dictionary, like orchestration means the act of arranging a piece of music for an orchestra. Okay, fine. So orchestration is coming from the word orchestra. So orchestra, we know, right? Like there are like group of people who are like, someone is singing, someone is playing drum, someone is playing violin, something, some music instrument, right? So combining all those things, we are calling the orchestra, right? So this orchestration term is coming from the term orchestra actually. Okay, so let's see the second definition: an arrangement of events that attempts to achieve a maximum effect. Okay, so there is some event and which is trying to achieve the maximum of it. Okay, so like we can relate this one with this fourth point here: efficient resource usage. Okay, so we are taking the maximum benefit of something. Okay, fine. So orchestra, so generally if you have gone through this event orchestra, so you people must have noticed, right, ki okay, if someone is playing drum, someone is playing violin, someone is playing some music instrument. Okay, so let us suppose someone is playing drum. Okay, so if someone is playing drum, then drum need not to be played every time. Sometime it needs to be paused for some 5 or 10 seconds. Why? Because to match the music flow. Okay, like if some drum player telling you no, I will be playing drum in the constant flow for till the end of the orchestra, then it's not going to work out, right? It's not going to work out. So this is not the orchestra. Orchestra is something like uh, achieving some maximum effect, optimum effect, and with some changes. Okay, it should not be the constant but with some variable. Okay, so if someone is playing drum, so sometimes that the drum player has to lower down the beat. Sometimes it has to raise the drum beat. Okay, based on the flow of the music that time. Okay, and sometimes it has to be silent. Okay, so okay, so one thing is clear is here, like things are not constant, things are not monotonous, things are changing, things are variable here. Okay, just like I gave the example of drum player, right? If drum player is telling you no, I will play the drum with the same effect, same constant style from start to end, so this is not going to work out. So it has to change based on the music flow, music beats. Sometimes it has to lower down, sometimes it has to higher its beat, sometimes it's medium beat, so which is suitable for the music play. Okay, so this is the definition of orchestration, orchestra. Okay, so exactly what Kubernetes is doing, Kubernetes is playing orchestra actually. If you see, Kubernetes is playing orchestra. Okay, so let me switch to another screen. Yeah, so I told you, right, Kubernetes is helping us to achieve the microservices architecture. Okay, and what Kubernetes is doing? Orchestration, means Kubernetes is doing some orchestra, we can say. Okay, so Kubernetes is asking some drum player ki, okay, you reduce your bit pitch. Okay, just don't be so high. But after 2 minutes, okay, it's now okay, now the drum player is increasing its bit. Similarly, the other music player, other instrument player, maybe the violin one, they are also increasing, decreasing. So now let me try to map that with the here microservices architecture. Okay, fine. So to map this with, first let me explain you monolithic, some basic difference between the monolithic and the microservices. Okay, fine. So here in the monolithic, we know like our application is hosted in a IaaS. Okay, and it's a single execution context. Okay, execution context is only one, and we have one database shared across all the different APIs, we can say, or services. Like they are the logical separation of in like their logical separation, but still they are running in the same execution context. Okay, fine. So product service, order service, and payment service. So guys, be careful, like I'm trying to relate this with the orchestra. So I know I know that whenever someone will be opening my website, so definitely they will go to product service. That is for sure. Why? Because first of all, they have to go to product service to see like what products are available. If someone wants to purchase some product, then definitely they have to go to the product service. Okay, means they have to go to the product page, and the product page is hitting the product service. Okay, then let us suppose 100 customer visited the product service, but not out of the 100 customer, not everyone will place order, right? Out of 100, maybe I can say some 30 or 40 50 people will place the order. Okay, they place the order, somehow they came to the second stage. From the product service, they add to cart, they place the order. Okay, so whenever they add to cart, place the order service, this code block will be executed. Okay, and maybe there are chance ki after adding the product, maybe someone will do final checkout and they will purchase the product, or they may keep it in hold, they will keep it in the cart and they will not purchase. So here I have three logical separated chunks of the application. Actually this is only one application only. Why? Because it's running in a single IaaS having one database. But actually, practically speaking, this product service guy is taking more traffic as compared to order and payment. Payment, we can say like it's a very less traffic it is getting, negligible. Maybe out of 100, some 5 or 10 people only purchase at the end, or some 50% maybe get some order, will place the order. Okay, so here what we are seeing, like this application, in this application maximum load is going to this product service. Okay, and the order service and the payment service, they are like little bit relaxed. Okay, okay, so due to some reason my product service is that page for the product service is taking more time to load. Why? Because there is more load, more number of traffics on the product service. Okay, so the page is taking more time to load. But this order service and the payment service, like they are getting very less load as compared to the product service. Okay, so So definitely my frontliner means my product service, it will be taking some time. It is page, now the page is loading, it's not giving the immediate response. Okay, so it is taking some time to load. Okay, so somehow I inspected the application and found out that okay, I need to increase the memory and the CPU cycle, CPU resource for this IIS, for this server. Okay, then maybe what I can do, I will scale up. I will give earlier, let us suppose some 1 GB of memory and 100 CPU units has been given to run this application. Okay, but now I need to increase the CPU counts. So what I will do, okay, I will increase 50 CPU counts, 50 CPU cycles, entire the application. Okay, what I'm doing here, I am giving the extra memory or extra CPU cycle to entire application, not particular product service. Okay, but actually guy who is working very hard is product service, but while giving, I'm not giving to this guy, I'm giving to everyone. Okay, so it's kind of, I can give you some example out of context. Let us suppose in one in a IT company, in a team, let us suppose 5 people are there, a team of 5 members. Okay, and out of those 5 members, let us suppose only 1 or 2 guys are working very hard to make the project success. Okay, and rest of other like, they are not getting much work. Maybe we can say the example of DevOps guy or the DB guys. So they are not getting much hit. Okay, so we can say, yeah, QA guy, they are getting more hit. Why? Because they have to test every application. Developers are getting more hit. Okay, so let us suppose 2 guys are working very hard. Okay, but remaining other 3 guys are not getting chance to work hard. Okay, why? Because practically there is no need for them to work hard at that time. Okay, but what I am doing, I gave additional 50 GB of memory and some additional 500 CPU cycles to entire application. Okay, so this is not fair. Why? Because let us suppose only these 2 guys are working. So why I'm, so let us suppose some resource is coming, so it should be going to the guy who is working more. It should not be go blindly to all the people. See, let us suppose I have added additional 500 GB of memory. Okay, so everyone will get equally. Okay, then what is the use of extra memory here? No, right? On the other hand, this guy is not getting the sufficient resource to execute this, and here we are wasting our resource. So it's kind of like we are spreading our resources, and it is going everywhere wherever it is not required, and maybe the one who is required is not getting the sufficient resource. Okay, so we need to identify this, who is working hard, so we can reward that guy specifically so that he can perform some more. So now let's try to relate this example with the orchestra, what I am telling last time. So drum guy. Okay, so let us suppose this product service. So let us suppose this product service in the normal time is not getting that much traffic, but in some festival season it is getting more traffic. Okay, so whenever it is getting more traffic, whenever there is a need of orchestra guy, drum guy to hit some higher volume, so definitely it has to hit higher volume. And here, whenever there is a need for me to assign some additional, or what I can do is I can make 2 product service. Let me make 2 product service. So this is one product service is there. Okay, one product service is there. So what I did, I will make the two product service. Just try to adjust, guys. So I make the two product service. Okay, why? Because I see that like one product service is not enough, is not able to handle the traffic. So let's add one more product service, just to add one more replica of this. Okay, such that it will be easily handling the traffic. Similarly, the drum guy. Okay, drum guy, please, now you have to raise your bit, you have to raise your pitch, so that the drum guy will start putting hard the drumsticks on the drum, so that he can match the music beats, such that the product service can match the request, the hit in the festive season. Okay, so when our monolithic application was there, the monolithic application service is not smart enough, I can tell you. The monolithic is not smart enough to detect okay, which guy needs more support, more resource. It will blindly come and it will give some resource which will distribute it among all, but this is not fair. Okay, let us suppose in orchestra, if I will ask, okay, raise the bit, increase the bit, and let us suppose if every instrument player, drum, violin, everyone will increase the bit, then it is of no use, right? At certain point I need uh, drum player to increase the pitch. At certain point I need the violin one to increase or decrease the pitch. So similarly, I should be here able to identify okay, which service need how many like which service need how many resource at what time. Okay, so we can say our monolithic application is not smart enough to detect this and to assign the resource properly. Now coming to the microservices. In microservices I have like 4 services, like how we had here 3 services, here we have 4 services. Okay, catalog service, shopping cart service, discount service, order service, and these 4 services have their own database, like the database is not sharing. Okay, they have their own database, separate database. So see, like this is separate, different. Okay, so when the request will come, and this API gateway will determine ki, okay, now the request is going to catalog or shopping cart. So whenever there is more need of catalog, there is more demand for the catalog or the more traffic for the catalog, then microservice is smart enough to provide additional resources, additional CPU or additional memory to this catalog. Okay, maybe it will increase the CPU, or maybe it will create another replica of this catalog. If it is creating the another replica, then it is called as the horizontal scaling, or if it is just keeping the same replica with higher number of CPU and memory, it will be called as the vertical scaling. So we will cover that going further, don't worry for that. So this is the concept behind, guys. So this is what I wanted to explain you. I wanted to relate like what is the Kubernetes orchestration along with the application. Okay, so how the Kubernetes is doing orchestra with our applications, our web services. So this Kubernetes actually like it's a Kubernetes cluster actually. So as we already know, right, like what is the Kubernetes, how it is helping one application to become a microservice. Okay, so like Kubernetes, like it's actually comes as a cluster. Okay, and a cluster have nodes. Okay, so generally we have 2 types of node, like one is master node, which is also called as the control plane, and second is the worker node. Okay, so in the beginning I told you, right, I did something here, like I developed some YAML file, I gave the container reference here, image reference of my Docker file, and it is going to create a pod. Okay, so this order YAML file, it will going to create a order pod 1, pod 2, like this, right? So whenever we are creating the YAML file and we are applying that YAML file, then that file is converted into the pod. Okay, and that pod is coming under the worker node. So in master node, actually it's we can say the admin headquarter, we can say, like they are not actually doing the exact work is getting done in the worker node. Exact work means like whatever pod we have, right, this pod. So exact work is getting done through these services, this order service or the platform service or the payment service or some XYZ service. So actual work is getting done here, and these people are sitting where? These people are sitting here inside the pod. Okay, so actual request is coming from the end user, it's fulfilled through worker node only. Why? Because actual work is happening in the worker node. But to handle, or to, we can say, the administrator or to manage the entire system, we need some admin, right? Without admin, without management, we can like we cannot do, right? Who will give our salary and all? So master node. Okay, so this node is like responsible for handling end to end for each and everything inside a Kubernetes cluster. Okay, so I will telling you, like this is just a overview, high overview. Going further, I will be showing you each and everything practically, like hands-on. While I will be doing the hands-on with the YAML file, then I will show you exactly where pod is, exactly how to see the pods, like how to see the how to get understanding of the proxy content, like everything I will explain you line by line when going through this practical. So this is just a high level understanding. So master node, like generally we have API server, etcd, scheduler, controller manager, and cloud controller manager. And here in the worker node, we know, right, like pods, whatever pods we are pushing, like these are coming to the worker node. Okay, so in worker node, along with these pods, we have three more components called kubelet, container runtime, and the kubeproxy. Okay, so kubelet, like what is kubelet? So we can say like kubelet is the manager of the worker node, we can say. Okay, so actually this is the headquarter. Okay, this is the headquarter, we can say, and this is one of the zonal office. Okay, maybe east zone, north zone, okay, some office, and this is the headquarter. And let us suppose something is not happening wrong, something is not happening right, something is wrong. Okay, let us suppose this pod 2 is not behaving well, it is failing again every 10 seconds, it is failing, it's not running up and running, it's not running properly. Then this failure information someone has to pass to the headquarter, right? Okay, some employee is not working properly, some employee is doing politics here, is not following the protocols, then someone should be passing the information to the headquarter, right? So this is the guy, kubelet, who will be in the touch with this master node, like communicating with all the pod health and every behavior of the worker node. So we can say the captain of the ship, or maybe we can say like captain of the flight. Okay, so this is a flight, let us suppose. Okay, we have all the pods and everything we have. So if something is getting wrong, then the captain is informing everything to nearest ATC tower, right? So we can say this is the ATC tower who are controlling the flight movement, like at what time who has to land, at what time who has to take off, everything. So we can consider this as a captain or manager, whatever you can say, for the worker node. Second is the container runtime. Container runtime is something like okay, fine. In the Docker file, you must have noticed, right, what I am doing here. I am pulling the image from the Microsoft container registry for building and running this application. Okay, this web API. So I know, like wherever this web API will go, I am not expecting to install the .NET runtime and whatever XYZ DLLs to support this, to support the running of this application, right? So this is not going to be possible. So what it is doing, like it is keeping the image where it has all the required runtimes. Okay, so now this Docker file is building the Docker image to Docker container, and now from Docker container it is going to pod. Okay, so in the pod, what it is coming, in the pod it is coming our application along with the runtime. So to run this pod, definitely some runtime is required, right? .NET runtime. So this is the job of this container runtime. So this guy is responsible for fetching the necessary runtime to up and running to work this pod. And third component, a kubeproxy, like which is responsible for communicating among the pods. Let us suppose there are some 100 pods or some 50 pods. Actually in production, if you see, I told you, right, in one of my organization I worked around some, there were some 20 to 25 pods were there. So these pods sometimes need to communicate among each other. Okay, sometimes they need to talk to each other, like pod 1 maybe needs some service, some data which is available with the pod 2, then it can communicate with pod 2 and like it will get the response. Okay, so this will be possible through kubeproxy. So yeah, again, like communication among the pod, like there are two different types of synchronous and asynchronous. Synchronous is through HTTP calls, and asynchronous through like we can say Kafka. You can use the messaging system, Kafka messaging system, or RabbitMQ we can use, like pub sub model, publish and subscribe model. So like, okay, that's why definitely I will going to cover this in future videos, don't worry for that. So just focus on the high level thing. Yeah, so I think like I have explained uh, enough for regarding the Kubernetes, like how it is taking the Docker things and making the, how it is doing the orchestra. Just you just guy remember like how Kubernetes is doing orchestra. Okay, orchestra means, orchestra means like, orchestra means like it is spinning or it's replicating the parts as per the need. Okay, there should not be any failure for the end user. End user should not be returning with the error key, okay, there is some memory timeout or some request timeout. It should not be the case. Okay, why? Because we know our microservices is smart. Okay, it's not like not smart like monolithic application. It's not like that, but yeah, it's smart. So they can detect and they can apply like, okay, how much resource this particular this guy needed. Okay, so yeah, I think this is enough guys for today. In next class, like I'll be focusing on the practical like hands-on session, like how we will be creating the pods and what are the commands to create the pods, and how to see the pods, how to see the nodes, how to make communication between the like pods. So this we, or everything we will see in the next session. And before winding up, I want to make sure one thing: you don't think that microservices are the replacement for the monolithic architecture. Okay, it's not the case. Okay, even though this system is not smart, it's enough. Let us suppose there are some application which doesn't need any variance traffic or variable traffic, we can say. Okay, if I have a application and I know like 365 days I am going to get this much amount of hits or this much amount of traffics, let us suppose per day I am expecting some 400 traffics per day, and it's not going to change, it will be fixed throughout the year, then definitely I no need to be a smart, right? Even the dumb guy can do this job. So yes, if my requirement is like that, then no need to go to switch to microservice. Please guys, it's not like a fancy word like okay it's microservices meant we have to go to micro. It's not like that. It's need basis. Okay, if we have a need, like what is the need? The need is like, okay, I don't know at what time certain component request will increase. I don't know. Okay, if I am uncertain about my audience, about my customer, at what time what hit I will get, how each and every service should behave. Okay, if I don't know, then definitely I will go to microservices, and microservice orchestration Kubernetes will help me to figure out. But if I know कि throughout the year every day I am expecting maximum 400 hits, not more than that, some 300, 350, 400, but not more than that, then I no need to spend the resources and spend the money for microservices. Why? Because microservices coming with huge cost. It's not easy guys. We have so many things to set up. Okay, so yeah, so in that case I will definitely manage with the monolithic architecture. So it's not like it's very bad, it's not bad, like it's not like that. It's need basis, based on the requirement. So I hope everything is clear guys. If you had any question, then you can definitely ask in the comment section. And I will say, like, if you like this video, please like this video, and please subscribe to my channel, and please share this with your friends. Thank you guys.